Hello everyone. In my last video, I have covered the basics of BLE, that is Bluetooth Low Energy Technology, in which I have covered the mode of communication and the GAP and GATT protocol as well. Now in this video, I will discuss about generic protocol, means generic attribute, that is GATT protocol. This protocol is helpful to implement one-to-one communication between the central and the peripheral. So before starting this video, I will suggest you that if you did not watch my last video in BLE Basics, please watch it, and the link for the video is given below in the description. So now I am starting the video which will cover the following topics. Here in this video, you will learn what is the generic attribute, that is GATT protocol, what is the structure of GATT protocol, what is the GATT workflow, iOS CoreBluetooth framework, and reading and writing data in iOS by using CoreBluetooth. So now let's talk about the what is the GATT protocol. GATT uses the attribute protocol as its transport protocol to exchange the data between the devices. This data is organized hierarchically in sections called services, which group conceptually related piece of the user data called characteristics. A universally unique identifier, that is UUID, is 128-bit or 16-byte number that is guaranteed or has a high probability to be globally unique. In GATT protocol, each element has its unique UUID. Attributes are the addressable piece of information that can contain relevant user data, and one of the most common attribute is value. We store or read all our custom data in the term of value mostly. As you know, in the HTTP protocol, there is a TCP/IP protocol which work in the transport layer, right? So, in the same as the same like that, in BLE term, here GATT is working as a transport layer. GATT protocol is working as a transport layer protocol. Here, all type of data are organized as hierarchy of service and characteristic. We group the data in the term of attributes and group of attributes called characteristics, and sum of attributes of a characteristic is stored metadata which describe the nature of the user custom data, like is the data is readable or writable also. Can we subscribe the characteristics so that central will be notified whenever the user data will be modified? So these type of information this metadata attribute contains. I will cover all these all these detail in this video after some time. Okay, so now what is service? Service is a group of relevant characteristic is called service. Means service is a group of relevant characteristics, and each service and characteristic is uniquely identified by its unique UUID. Okay, so now let's understand what is the structure of GATT. There are two type of devices in BLE, as I already explained in my previous video. First is a peripheral and second one is central. A peripheral is a device that exposes services and the data for read and writing. A central connects to the peripheral in order to read and write the data of the peripheral. The central is the device that initiates the connection to the peripheral. In peripheral, we store the data in group of services and characteristics, and you can understand the characteristics as container of user data. So, and they always include at least two attributes. First is the characteristic declaration attribute, which provides metadata about the actual user data, and the characteristic value, which is a full attribute that contains the user data in its value field. So as I already explained about the metadata, that it describes the nature of the user data. So service is a collection of characteristics describing a specific function or feature of the peripheral, and collection of that service is called profile. For example, a heart rate sensor has a profile which have heart rate service. We have the service, and we call the service as heart rate service, and a peripheral can have more than one service. So the heart rate service contain heart rate measurement characteristic that contains the beat per minute data, and another characteristic that heart rate service may have is body sensor location. Body sensor location, which is simply a string that describes the intended body location of the sensor. So here you can see how the service and the characteristics and their attributes are organized. So the peripheral has a service, and a service has so many characteristics. Peripheral has so many characteristics. So peripheral has so many services, and a service has so many characteristics, and a characteristic has so many descriptor, and so these are the descriptor of the attributes. So characteristic may have so many attributes. So since we are storing everything in term of attribute, so that's why we call this protocol as generic attribute, that is GATT protocol. So now let's understand the workflow of the GATT protocol. So in order to read and write the data from the peripheral device, the central need to do the following work in the following order. First is the scanning peripheral for a specific service, then connecting to peripheral if found the device, then discovering peripheral service, then discovering characteristics in service, then checking characteristic property, then reading or writing the data, and when the reading and writing has been completed, then disconnect the device. So all the process so these are the 7 steps for the whole read and write process. So if I want to access the data from the remote peripheral, my central device must know the UUID of the characteristic and service for which I want to perform the read and write operation. So now let's talk about the peripheral scanning, the first step. If we know the UUID of that service in advance, so the central first need to search for the peripheral which should have contain the service of the given UUID. When it performs the search, the central can find so many devices which turn on their Bluetooth. But now the problem is that how we can know that which is the desired peripheral. The desired peripheral in the sense that which peripheral contain the desired service for which we are looking on. So to identify this, central check if the peripheral contains the service of the given UUID. If yes, then it moves to the connecting phase and establish the connection. Now move to the connection phase. After the connection establishment, the central discover the services in peripheral which have the same UUID which is given to the central. Means we have connected to the peripheral device. Then now the next task is to discover the service for which we are looking on. And then we move to the discovery. When we found the when we discovered this service, then because in the service we service may contain so many characteristics, so we need to discover that particular characteristic for which we are looking on. So when it found that service, it moved to to discover the given characteristic. Since within a service there may be more than one characteristic, so in order to access the data, we need to discover all characteristics which have the same UUID for which the central is looking on. And when we found that particular characteristic, then we need to check that characteristic property. We need to jump here. If the central found the characteristic, so before making any read or write operation, it will check other metadata attribute to know if the characteristic is readable or writable or subscribable. According to that information, we can perform the operation on the data. Means if the characteristic is readable, then only we can read the data. If the characteristic is writable, then we can only write the data. If our characteristic is allowing to us to subscribe for the data, then only we can subscribe the data. And after that, we can perform the read and write operation. Means that is the sixth step. And after that, when the read write operation has been completed, then we can disconnect the device connection. So okay, so till now we have discussed about GATT theoretically concept, and we have discussed about the theoretical concept of the GATT and how it works. Now let's understand here how we can implement this protocol in our iOS project. To implement the protocol, Apple provided a framework called CoreBluetooth. By using this framework, we can implement GATT. Now let's understand what are the basic classes which represent BLE entities and how we can achieve GATT workflow. So the central is represented by the class CBCentralManager and its delegate is CBCentralManagerDelegate. The peripheral is represented by CBPeripheral and its delegate is CBPeripheralDelegate. We can get the instance, or we can create the instance of the service by using CB service class, and for the characteristic we can use CB's characteristic class. In the central side, you can detect all the action related to the communication in CBCentralManagerDelegate methods and the CBPeripheralDelegate methods. Okay, so now let's understand what is CBCentralManagerDelegate. What is CBCentralManagerDelegate? So when you implement this delegate in your central site, you need to confirm central manager did update state to detect the current connection state. So these methods should be called by CBCentralManager. So when you create the instance of it, you need to pass the delegate class as a reference. Like you can see here, where central manager is equal to CBCentralManager and delegate. So we are passing self as a delegate reference to the CBCentralManager, because my self class, the container class is confirming the CBCentralManagerDelegate. So we are in this way we are passing the CBCentralManagerDelegate instance to the CBCentralManager, and all the methods of the CBCentralManagerDelegate will be called by the CBCentralManager whenever its related activity will be happen. Now the state will be power on when you execute this code. So you will get the state, either the state will be power on because your Bluetooth is on, but if the Bluetooth is off, the state will be power off. So Central Manager Delegate have the callback methods which will called by CB Central Manager when the connection related activities is happening, right? So when you implement the delegate with Central Manager did update state, this function only some function will called which let you know the connection state of the central. When you confirm when you pass this to the CB Central Manager, so their corresponding method will be called, right? So there are mainly six states of the connection. First state we can first is one of the six states are power off and power on, which we have described here, and another are unauthorized, means whenever the connection you are unauthorized to make the connection, means that the connection status is unauthorized. If the there are some compatibility issues in between two devices, so the connection state will be unsupported. If you are resetting the connection, then connection state will be resetting, otherwise by default the connection state will be unknown. Okay, so uh, now the first step is to scanning our peripheral. As you as our first step is here to scanning the peripheral. So how we can scan the peripheral by using CoreBluetooth framework. So we have covered here. So we have covered here. So if we want to scan the peripheral which have service, we must need to know the UUID of the service in advance. Create the service UUID instance, then call scan for peripheral of the CB Central Manager to scan the peripheral device which have this service. If it will detect the peripheral, then function Central Manager did discover advertisement data RSSI. That function will be called, where you need to stop the scanning by calling Central Manager.stop scan. As discussed in the workflow, the first phase is to discover the peripheral which has services of the given UUID. To scan that, firstly we created UUID instance by passing hex value of 16-bit UUID. You can see here we are creating the CB UUID instance. This is the instance we are creating for the UUID, and we are passing the hexadecimal value here as a string. Then we need to create CB Central Manager instance and call their scan function which accept array of UUID instance. You can see here in Viv.load we have created CB Central Manager instance here, and we are passing this delegate as a self, and then we are calling scan for peripheral, and in which we are passing the array of UUID. Since it accepts the array of UUID, it means we can scan the peripheral multiple UUID for the multiple UUID services. Means we can scan multiple peripheral for the multiple UUID by using that. When when the scanning will be successful, then this did discover peripheral function will be executed, where you can stop the scanning by calling stop scan. Okay, now this scanning process has been completed. Now we need to move to the connection phase. Second step of the workflow was connecting to the peripheral. So we can how we can connect to the peripheral in the CoreBluetooth we are describing here. After peripheral discovery, if you want to connect to that device, you need to call Central Manager dot connect, and you need to pass that peripheral here, where you need to pass the instance of the peripheral to which you want to communicate. If your device successfully connected to the peripheral device, your central manager did connect function will be called. From here you can start your next task, that is discovery of the service. So after successfully discovering the peripheral, next step is to establishing the connection. So in the did discover function we need to call connect function. Like here we are firstly we are calling stop scan to stop the scanning process, and then we are calling central manager dot connect, and we are passing this the instance of the peripheral. Sorry, I did not declare this peripheral. You can see this peripheral instance which we are getting here, we can pass here. So that means by calling this function we are sending the command to the central, hey, establish the connection to the peripheral. And when the connection will establish successfully, then this the central manager will call this did connect function. So when your did connect function will call, it means that the connection has been established successfully. Then my next task will be to discover the service. You can start discovering the service in which you have the characteristic of the desired data value. To do this, you need to call discover service, and you need to pass that array of the UUID to the peripheral object. Since it accepts the array of UUID, it means you can discover multiple services at the same time. To discover if the central found to detect if the central found the desired service on the remote peripheral, you need to implement the CBCentralPeripheral delegate also in your code. Like in my code. Okay, I will explain in next slide for that. So now there may be a chance that the connected peripheral may contain more than one service, right? So in order to access the data, our next step should be to access the service in which that given data may have. Since we have the UUID of the targeted service in advance, so we can start our search by calling discover service function, right? So here we are calling our discover service function, so we can search for that, which accept the array of UUID as a parameter. It means we can search many services simultaneously. So next step will be discovering the characteristic. So if you discovered services successfully, this method means did discover services, that method will be called. Here we have implemented this method, right? Sorry, did discover. Here I have implemented this method, right? When you will call the peripheral dot discover characteristic, it will discover all the characteristic of the particular service, since you are not passing the UUID of the characteristic which you want to search. Because here we are not passing any UUID, so it will discover all the characteristic. But if we know the UUID of the characteristic in advance, so we can pass that UUID in array, as an array, right? So you are passing nil instead of that. The same thing is applicable for the service discovery also. So now, if central found the desired service on the peripheral side, it execute did discover service function on CB peripheral delegate. Now we have reached to our desired service in which our data exists, but data exists as an attribute of one of the characteristics which are running in the service. So our next mission is to discover that characteristic in which contains that data attribute. We can use discover characteristic function for that, and see here we are passing nil for the array of the UUID. When we pass nil, either in case of characteristic or the service discovery, it scan all the available characteristics and services. So On success of our discovery, did discover characteristic for service function will be called here. This did discovers a characteristic for service, this function will be called, and all the available characteristic will be here. We can execute service, all we can get all the available characteristics by service dot characteristics, right? So here at this point, if you know the UUID of the characteristic, then you can apply the filter on that particular array, and you can search. But it is not, I am not suggesting you this is the not a optimistic approach. You can, if you know the UUID of the characteristic, then you need to pass that here. That is the best way. Now we have searched the desired characteristic, and so our next step will be the reading the data. Or before the reading the data, we need to check the properties. As you remembered here, the next step will be, after discovering the characteristic, next step will be checking the characteristics property. So we need to do that one. As acknowledgement of the characteristic discovery, the did discover a characteristic for the service will be executed. Here, this function will be executed. Here, the characteristic may have the following properties: read and notify. Apart from this, it may contain write property also, because see, the characteristic may have so many properties, but the read, write and notify, these are the main properties. So in the read, you can directly read the value by sending the command to the peripheral by calling read value function, right? And if in case of notify, you need to subscribe to receive the update when the data will be updated. You can subscribe it by sending the command to the subscribe by calling set notify and passing true for the particular characteristic. So now we have extracted all the characteristic of the services from which we need to access the data, right? Here we have extracted all the characteristics, but before accessing the data, we need to check if the data is available for read or write or the subscription purpose. If the data is not, suppose that if I want to read the data, I am trying to read, but that data is not available for read purpose, or that data is not available for notify purpose, then our process will not successful. It will send me the error, right? Runtime error. We can do the same by checking some property of the characteristic, which are metadata properties of the user data. As I already explained you that there are two type of properties, characteristics attributes are there. First type of attributes are metadata, and second one is the actual data which we want to access, right? So these read, write, notify, these are the metadata properties, and we need so characteristic class have the array of the properties, and if that properties contains this read, it means that we can read the property. If it contains the notify, it means we can subscribe the property. If it contains the write, it means we can write the property. Otherwise, we can't do such type of operation. So checking this type of permission, checking this type of property is an essential part of the our coding, right? If characteristic properties array contains the desired property for which you want to check, you should think that that type of action is permissible. For example, here in this code, the property array contains read and notify properties. We can say that we can read or subscribe the characteristics. You can ask the system to read the data by calling peripheral.read value. Here we are calling peripheral.read value for the particular characteristic. So we if we are calling this value, if we are calling this method, it means that we are asking asking for the central to read that particular value, right? And but if you want to subscribe the data so that you can read all the further upcoming changes without any further request, then you need to call set notify value. And then in case of in that case you need to pass true here, right? As if you are passing true, it means you started your subscription. But if suppose that if you want to stop your subscription, then you need to pass false here, means you have stopped their subscription. So if in both cases, yeah, so when you will receive the data from the peripheral on either by subscription or read request, the peripheral did update value for the characteristic function will be executed. Here in this method, you can read the data by using characteristic dot value property. Here the characteristic dot value is the data value type. So you need to convert the value from the data to a string or any other data type on which you want to use, right? So after those requests, after those sending those read or subscription request, the peripheral will send the value of the data. But that time when the central receive the data, it calls did update value. This function did update value for the characteristic. So in both cases, either you are sending the read request or the update sorry subscribe request. So in both case, whenever the peripheral will send you the new value, then CB Central Manager will call this method did update value for characteristic, this method, right? So here you can read that value by characteristic dot value property. So this property gives you the data in binary form, and you can convert the binary to the other data types. And the last but not least operation is writing to the peripheral. Apart from read and subscribe, you can also write and update the data to the peripheral for any given characteristic. Like in the client server architecture, you can the client can write the data on the server by either using put or post put and post methods. So here also the central can update or write the value in the peripheral by using this approach which we are explaining here, right? So we can write the data by calling peripheral dot write value, and here we are sending the raw data. The value is raw data for that particular characteristic, and the type will be either will be with response or without response. Here the value is the type of data. Here there are two type of write operation. First is the with response. If you are passing with response in a type, then you will get the acknowledgement. Then your means you will get the acknowledgement when your writing operation will be successful. In this case, this your did write value for the characteristic, this function will be executed. But if you are passing this type means without response, then this function will not be executed and you will not get any acknowledgement. So this was how we can implement GATT protocol for central side. In the next video, I will cover the peripheral side implementation also. And if you feel that this session is really added some value in your knowledge, please like, share and subscribe the video, and don't forget to forget to press the bell icon button, so that you will notify when my next part of this video will be available. Thanks for watching my video.